All right, as we start back up, then why don't we just do this together? I'd like everybody to go to your desktop or wherever you put things. All right, with me it's a desktop, and I'm going to create a new folder, and I'm just going to call this JS practice, one word, just JS practice. All right. And then open the folder up once you've got it. Inside of that folder, put another folder, call it JS. And just like we did before, we'll call it scripts.js. It's not a great name, but it's fine. And also put an index.html file in here. So if I said that too fast, I'll say it again. And that is what you should have when you get done with this is a new folder that we call JS Practice. In that folder, JS Practice, there should be another folder called JS. In that JS folder, make a file called scripts.js. And in your JS Practice folder, make a file called index.html. That's all I want you to do. All right. Then once you've done that, right mouse click on the folder, on the JS Practice folder, and open it up with code. Okay. So this is what it should look like when you get done. All right. And the reason for doing this is I now want to show you the different kinds of variables that are available in this language. All right. So looking in your book, it says when you develop JavaScript apps, you typically have to work with data. JavaScript provides 7 primitive data types, which are shown in your book on page 67. Now, if you look at the chart, either in your book or up on the screen here, JavaScript's a little hinky in that when you declare numbers, JavaScript could care less whether it has a decimal place or not. They're all considered type number, whether they're a whole number or a number with a decimal value in it. Strings, I already mentioned, basically it's a string of characters. You can put them in single quotes, you can put them in double quotes, but you can't mix them. So you can't start it with a single quote and end it with a double quote, etc., or vice versa. Boolean is true or false. You don't have to do this, but what a lot of people do when they create Boolean variables, they start them with the word is. Is married. There is no gray area to the computer. Is married is equal true, or is married is equal to false. Does that make sense? All right. Symbol I don't want to get into right now because it's just a little different. It's fairly new. Null means unknown. I may have mentioned this earlier in the semester. I don't know. But for you people who started this semester, if you came in the first day and I said, hey, Mason, what's your GPA? I wouldn't say that anyway, but if I did, I don't know, I just started. I don't have one. I guess it's 0. No, it's not. You're not failing anything. It's null because it's unknown. That's what null is. All right. Undefined is something that you've declared, but you haven't given it a value yet. And I'm going to show you all these in just a minute. I shouldn't say all of them because out of these 7, we're going to concentrate on number, string, Boolean, null, and undefined. For now, at least, we're not going to care about symbol or big int. All a big int is it's a really big whole number. So if we wanted to show the national debt, which from the last time I heard was several $1 trillion, you'd do it probably using a number like that. All right. So jumping back into our file then, I'm going to come into the index.html, and we've done this many times before. So I'm going to put in my exclamation point, and I'm going to hit tab. All right. I will give it a title. I'm just going to call it JavaScript Practice. All right. And then I'm going to put in a link to my JavaScript file. All right. So I'm going to say here, script source equal js/scripts.js, and then I'm going to end my script tag. That should be, I could be wrong, I don't think I am, that should be all we need in this file, at least for now. All right. So I'm going to do a file save just so I've got it. And now I'm going to open up in my JS folder, I'm going to open up the scripts.js file. Now, some of this you've already seen. So let's just start by, we'll say here, I'm just going to have one big variable. I'm going to say I don't know what I did there. I do know what I did, but I screwed up. So I'm going to say here, let name equal, put your name in there. Put your whole name, it doesn't matter. All right. And then let age equal, put your age in there. I'm not seeing this. Make up an age. It doesn't matter. I don't know if any of you in here are married. Not to be mean, I don't care. But I'm going to say let is married, I am. So I'm going to set that equal to true. All right. So right now, that's 3 of those 5 data types. All right. Now, I'm going to say here, let salary, and I'm not going to give it a value. I'm not giving it a value. All right. And then finally, I'm going to say, let, I don't know, interests equal, and I'm going to set that equal to null. Okay. What we've just looked at here, you don't have to add this, but I'm going to put a comment over each one of these. So I'm going to say here, string variable, number variable, Boolean variable, undefined variable, null variable. Now that should make sense to everybody, even if you don't know what those words mean. All right. So I'm going to come out here, and what I want to write down is just these 3. So in other words, I want to write the name, I want to write the age, and I want to write the marital status. Does all that make sense? All right. So I'm going to come in here and I'm going to say this. We'll do it as an alert. We can do it as an alert or a console.log. Again, it doesn't matter. But for now, I'll just do it as an alert. And I'll say, in fact, I'm going to use the template literal. So I'm going to say name, age, and marital status. Now, if I didn't screw up, it should come in there and say name Jeff. All right, it should say age 64, and it should say marital status true. Does that make sense to everyone? My guess is you all put a different age in. Unless you put in my name, you've all got a different name in there. Now you look in here and you say, you see that name is, it says, it actually thinks when we're using name, we're trying to use it as a JavaScript keyword. And that's why it's saying it's deprecated. It doesn't hurt anything that it's got that line through it. Don't let that bother you. Now, look on the screen, please. I'm going to do this next. I'm going to say alert, and I'm going to say salary, and I'm going to put in there, oops, sorry, let me use the template literals again, my fault. And my guess is this is going to give me an error message. Why? Can somebody want to take a wild guess as to why it might give me an error message? I haven't defined it yet. It's undefined. All right, and I'm not sure what this one would print out, but I'm going to try this one too. So I'm going to do an alert. Again, using my template literal rather, and I'll put in here interests. All right. So you're writing your first JavaScript file. We're starting by declaring different JavaScript primitive variables. Okay? And then we're just attempting to print them all out. Does that make sense to everyone? I'll give you time. I'm not trying to rush you through this. But is there anybody who doesn't understand what we're doing in here? All right.
Question?
Yes.
My template variables, my template literals are not coming up as like that. They're just still basic strings.
You are using the backticks.
That is exactly what's missing here.
Other questions? So I'm going to save this. I'm going to go back to my index.html file, right mouse click, and I'm going to open it with Live Server. All right, name Jeff, age 64, marital status true. Well, that's all good, right? And I click OK, and it says salary undefined. Remember, we just said let salary. We didn't give it a value. So it told us the value was undefined. In other programming languages, don't look, but please listen, not JavaScript, but in other programming languages, that would crash your program. JavaScript is very nice that way. All right. And interest, yeah, it's set at the null. So you now have seen the different types of variables that you have, and these are the different types of primitive or simple variables. And I've given this before. Maybe I did it to you guys. If I did, sorry. And if I didn't, then you're hearing it now. But again, I'll always remember this, that I took a child psychology class when I was at the University of Wisconsin-Milwaukee. I got to know the teacher a little bit. He was wound a little bit differently. But one of the things he did was the first day of class, we're all sitting in there, and it was in a big room, 500 people in the room, all right, and no window, or a window which didn't open, and they didn't have the door open, and the air wasn't working well. He was watching us to see how we were going to react to everything. Well, I always thought what would have been cool would have been if he would have given each one of us a Lego and said, your teacher will be here in 15 minutes, here, play with this. Well, how much can you do with a Lego? Not much. But if I say, hey, Mason, let me borrow your Lego for a second. Michael, let me borrow, then all of a sudden we make something. Each individual Lego is a primitive value. When you put them together to start making something else, it's a data structure, it's an array, or it's an object, etc., which we're not going to worry about right now. We're just worried about simple stuff. All right? So hopefully that worked for everyone. All right, let's jump back into the book then. So an integer is a whole number. All right, so a regular number can be a whole number or a number with a decimal. All right, a string can be in single or double quotes. You can also have the empty string. So if I did not know somebody's name, I just met somebody for the first time, I could say student 1 equals, and I want to give him a name, I can't. I don't know what it is. I could say either single quote, or double quote. That's called the empty string. If you do that, don't put a blank space in there. A blank space is not the empty string. It's a blank space. There's a difference between them. Again, a Boolean can be true or false. Now, just to show you this, one of the, for lack of better words, I'll use it, poor things about JavaScript is it's what's known as an untyped language. What does that mean? That means that after I do all this, would you agree that's my name? I can come down here and say, let name equal 456, and I don't get an error. I just changed the type of variable that's in name from a string to a number. Totally legal in this language. Totally illegal in almost every other language. Then later on in my program, so just imagine I had some code in here, but I could say let name equal true. Now it's a Boolean. So I can do stuff like that. JavaScript gives you almost maximum flexibility in that it lets you take what you have put into primitive variables and change the type of variable at any time. You might say, well, that stinks. Well, what about this? What if I wanted to put this down, and let's say I have a thing in here that says let test score, and I'm just going to make that number up equal 51. Okay, totally fine. But what if later somebody puts in 1,000, which doesn't make any sense if the test is from 1 to 100? I could say let test score equal illegal value input. So I could use the same thing to hold either a number or a string if I had the absence of a number or a number was out of range or whatever. All right. All right. So we talked a little bit about variables already. There's their examples. Could have looked at theirs. And I mentioned what a constant was. Again, a constant is literally says that while the program is running, you're not to change the value of that variable. All right, let's see what happens if I do that. You've already seen this before, but I'm going to come in here and say, I'll put a constant in here. It's most people, not all, but most people, if you're going to put constants in a program, they put their constants at the top of the program. It's just kind of an unwritten convention. So I'm going to say here, define program constants. And I'm going to say const inches in a foot, and I'm going to set it equal to 12. All right. And then I'm going to come in here, kind of a stupid thing to do, but I'm just going to say alert, put in my backtick, there are inches in 1 foot. Now, I'm asking this question. Does that make sense to everyone? That should print out there are 12 inches in 1 foot? Does that make sense? All right. Let's see if indeed that's what it does. Doesn't like something. All right. Says, oh, because I put that goofy stuff down at the bottom of here. So let me get rid of that. Try it again. There are 12 inches in 1 foot. That's what you'd expect to happen, right? Okay. But I'm going to come in here now. Now it's got the age and all the other stuff. Yeah, that's fine. Okay. I don't really need that stuff to print anymore. You've already learned this. So I'm going to take all 3 of these and I'm going to highlight them and do a control / and comment them out. All right. So now I want to come in here after I printed this out and I'm going to say inches in a foot equal, guess what? I just changed it. I want it to be 13. All right. I want that. So that's what I did. I'm going to come back in here and I'm going to run this again. And it says there's 12 inches in a foot and then nothing. But if I go back and inspect and I look in here, it tells me assignment to a constant variable. So it's telling me I'm doing something against the grain, something I'm not supposed to do. Now, good, bad, or indifferent, constants are a weird thing in this language because sometimes you can change them. I'm not going to talk about that right now because you can't when it's a simple variable like this. But when it's a data structure, like an array or an object, then you can change it. All right, so we'll talk about that, just not right now. All right, let me jump back into the book then. Now, I don't want to read all this stuff to you, but I'll look at just this paragraph, the second paragraph on page 70. When JavaScript loads, the JavaScript engine scans it and stores any variables and constants you declare with let, const, or var in memory first. So in other words, even if you declare your variables at the end of the program, which is a bad idea, typically JavaScript looks at all of them and says, oh, I'm pushing them up to the top anyway. That's called hoisting. That said, don't do that because it's a bad practice. You can't do that in other languages. So why learn bad habits when you'll have to unlearn them when you go into other languages? All right. And here they talk about why you really shouldn't use var and why you should use let. Again, the main thing is you use let because it's the right thing to do. All right. Okay. Let's go back to the program. We're going to look at each one of these, and some of them will be new to you. All right. And that's fine. So I'm going back to the program here, and I'm going to take everything that I had. I'm just going to get rid of it. I could comment it out. I'm just getting rid of it. It's okay. You could do the same thing. You can leave it in there. If it helps you, comment it all out. All right. But I'm going to come in here and I'm going to declare two numbers. So let number 1 equals 17. Let number 2 equal 3. All right. Then I'm going to say let sum equal number 1 plus number 2. I'm going to steal this. Let diff equal number 1 minus number 2. Let prod for product equal number 1 times number 2. Let the quotient equal number 1 divided by number 2. And then finally, I'm going to put another one in here that you may or may not have seen before. Let the mod equal number 1. And I'm going to put in here a % sign from number 2. All right. Now, I don't want to insult any of your intelligences. All right. So you would think, at least, I would think, this is going to be 20. Make sense? I would think this one is going to be 14. I would think this one is going to be 51. I would think this one is going to be 5.6666, something like that. Does that all make sense? Finally, just so you know, this is the remainder operator. 17 divided by 3 is 5 with a remainder of 2. Does that make sense? So I would think that's going to be 2. All right. So now I could sit there and I could have 5, if I wanted to, I could have 5 different alerts and print out each one of those. Would you agree with that? All right. But I'm going to do it in a way I think at least is a little bit easier. And what I mean is this. I'm going to create a new variable that I'm going to call str for string. That's all it is. There's nothing special. There's nothing special about str. Just want you to know that. But I use it a lot because it's a string. And I'm going to put in here this. So I'm putting in my backtick. So I'm going to say sum difference product. Forgot my colon there. Quotient and that last one is actually referred to as modulus. Let me do a word wrap on here. All right. Again, my word wrap is turned on. Don't just get to the end of that line and hit enter. Then I'm just going to tell it to do an alert of str. All right. Now, I'm saving. Let me run it, make sure it works, that I didn't screw it up. Okay? And then we'll come right back to it. So let's see. See, it doesn't like something, so I must have done something incorrectly. Okay, that's fine. Product is not defined. Oh, I know why it's not. Because that should have been prod. If that's all I got wrong, I feel pretty good. So, sum, difference, product, quotient, modulus. See that? All right. Now, when you use alerts, alerts are a little bit weird. All right. I don't remember, I never do, but I'm going to try to put in here \n because I want each of these to appear on a new line, and I don't know if this is going to work or not. If it doesn't work, I'm going to go back and use our old BR tag. So I'm putting a \n in between each one of these. And it worked. See that? So this is what we have. We are creating, I came in here and created 5 different variables, each one to represent the major arithmetic operations that you're going to perform most of the time on your variables. Addition, subtraction, multiplication, division, and modulus. And before you say, well, who cares about modulus? I'll tell you the 2 times modulus is used the most. If I said to you, well, how many hours are there in 184 minutes? You'd probably take 184 and divide it by 3, right? Or no, 184 divided by how many hours are there? Whatever. You'd do it. You'd figure it out. It was 3. 60 minutes in an hour. So you take 184 and you divide it by 60. And that would give you 3 point something. All right. But if you wanted to know that percentage, you'd use a modulo. So when you're working with time values or when you're working with dollars and cents. So if I said, hey, take 987 cents and set it up the best way you possibly can for the number of quarters, number of dimes, number of nickels, and number of pennies, you'd be doing a lot of work with modulo, just so you know. All right. Now, that's most of them. What did I miss? Close a few of these here. Plus, plus, and minus, minus. These are a little hinky, for lack of better words. What do I mean? Well, if I want to add, so after I did all this, let me go back. We did this, remember we did this before, and I said, let age equal 64. Remember that? Well, it's not, but let's pretend, hey, it's Jeff's birthday. So we want to add 1 to Jeff's age. I want to show you 4 different ways that I can add 1 to my age. Are you with me? Now I can either say age equals age plus 1. Nothing wrong with doing that, except it's a lot of typing. Doesn't look like a lot, but one thing is programmers typically don't get into the field because they like to type. I can also say age plus equal 1. That's a shortcut. Or, and this only works if the number is 1, I can say either plus plus age, or I can say age plus plus. All 4 of those will add 1 to the age. Now, if I ran all of them and then printed out age, it would say 65, 66, 67. It would say 68 because I've done it 4 times. Does that make sense? All right. The other thing that people get confused on is, okay, if these are the same, then why the hell do they give me 2 of them? That doesn't really seem to make a lot of sense. All right. So let's just say that I wanted to do this. I'm going to make up a variable here, and it doesn't mean anything. I'm just going to call it let x. That's it, just x. All right. There's a difference between this and this. These 2 are going to give you different answers. All right. The first one, this is called a pre-increment, and this second one is called a post-increment. So what's the difference? All right, even if you're still typing, please stop for a second because I want to show you this. And that is this. This adds 1 to age. So it makes age 65, then it assigns it to X. Does that make sense? It does the incrementing first. With the other one, it's a post. So it says add 1 to it. In fact, let me try this again. This is going to say plus plus age. So it says add 1 to age and assign it to X. This one says take age, which is 64, and assign it to X, then add 1 to age. So the difference is with on line 22, X equals 65 and age equals 65. With the second one that we did, the one on line 23, X equals 64 and age equals 65. And if you say that's confusing, I say then don't ever use it like that. The main reason that people use these two instead of these, this is actually going to execute the slowest. These will execute faster than that one will. All right, and if speed is of the essence, that may or may not matter then. If you need more examples, and you can always change this, by default, you do multiplication and division and modulo before you do addition and subtraction. If you want to change that, you probably learned this in junior high math, you use parentheses. The same thing works here. All right, so if I say something like this, I'm just making this example up. I wouldn't put it down. It's not worth it. I'm going to get rid of it right away anyway. But if I came through here and said, let X equals 7 times 3 divided by 6 plus 4 minus 1 times 8, something like that. Well, it goes through here and it says, okay, this and this and this must be done first. So the first thing it's going to do is 7 times 3. It's going to say 21. Then it's going to take the 21 and divide it by 6, and it'll be 3.5. Then it'll do the 1 times 8, which is 8. So you've got 3.5 plus 4, which is 7.5, minus 8. So the answer to that will be negative 1/2. Again, if I wanted to change that and do the 6 plus 4 first, I'd have to come in and do that. All right? And as always, the best way to learn that is to just sit and make some examples up and play with them a little bit. All right. There are some shortcuts that are in here too, and there's even more than they show. I already showed you that plus equals. You can use plus equals, you can use times equals, you can use multiply equals, you can use divide equals, you can use modulo equals. They all work. All right. So in other words, you already saw the example that I did for you. I probably removed it now, but where we did that and I said X plus equal 1. You could have said X times equal 1. You could have said X divided by equal 1. You could have said X modulo equal 1. And I should put them really in the right order. So you could have said X minus equal 1. And again, these are shortcuts. For what? This is X equals X plus 1. Just copy all these down and change the sign. Minus times divided by and modulo. So you can use any of those. All right. If you're more comfortable doing it the old-fashioned way, then do it that way for now. All right? All right. It says when you do some types of arithmetic operations with decimal values, the results aren't always precise. What does that mean? Well, I would think that if I did this, if I came through here and said, let x equal 0.1 plus, and I'm just going to copy this, 6, 7, 8, 9, 10. So I put it in there 10 times if I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I say, let's do a console.log for this. I'm not even going to say x equals, I'm just going to print out x. All right. So let me save that. Let me go back to here. Hopefully I didn't put anything in here where it's going to break anything. Wrong one. Yeah, I did. X has already been declared. Well, that's my own problem. So I've got, yep, there's that let x we did before. All right. Try it again. Still got those. That's good. And if we go down and inspect, look at that value. It's not 1 because math with decimals is never an exact thing. Some languages it's more exact than others. All right. That's actually pretty dang close, to be honest with you. I've seen a lot of them that aren't that close. All right. How to concatenate strings. Guess what? You already have seen this. You can either use the plus sign, you can use plus equals, and you know how to do it using the template literals, as I've shown you all those. How to include special characters in a string. Guess what? You've seen that. This is the one you're going to use most of the time. \n for a new line. \t, which is not shown on that list, I don't know why, can typically be used for a tab. But alert doesn't like the \t. It doesn't recognize it. At least it usually doesn't. All right. But \n allows you to put in a new line. All right, that jumps us up to page 80 here. How to use objects, methods, and properties. Now, this is actually a little bit, I'd say at least, important. And that is, I'm going to go back to the program. All right. And now I want to get rid of my constant because I don't care about this. It's inches and a foot. I'm just getting rid of it. All right. And I still want to do all my math that I'm doing right here. I still want to do this. I'm going to get rid of this. But I think you'd agree that every time we run this program, those are the answers that we're going to get. Does that make sense to everybody? Why? Because we're hard coding the values in here, and here. All right? We're not going to hard code them in anymore. So we're going to come in here and we're going to add a new statement. It's called the prompt statement. So I'm going to say prompt, and I might as well just teach you the right way right away. And I'm going to say in here, parse int, please enter a number. And I'll even give it a default. I'll say 34. All right. And now I'm going to come in here and say, please, oops, prompt. Sorry. In fact, I'll just copy it. Please enter another number. And I'll just make this 56. There's no significance in these numbers. They're just something I made up. And if you would, please just stop for a second and look on the screen. This is the #1 error, as far as I know, that's made by people who use JavaScript. Notice 1, 2 parentheses, 1, 2 parentheses. You don't have to put in a default value. And I can't tell you the hundreds of times I've done that. I don't have 2 ending parentheses. Everybody does it. The good news is, since we're not using a simple editor here, since we're using an IDE in Visual Studio Code, did you notice it caught that? It put a little red underneath it. It's trying to help me. All right. So let's look at this. So I'm going to save this, and I'm going to go back, and I'm going to run it. All right. And it says NaN. Ooh, that ain't good. Okay, well, we'll fix that in a minute, but let's look. So I'll put in 45, and it's got NaN again, and that's okay. But I'll leave 56 in there. All right, it doesn't like something. Oops. But it's not giving me any errors. Geez, well, what's the problem? Let's see if we can debug what the problem is. All right. Okay, it's because I did this backwards. The prompt should be inside, the parseInt should be on the outside. Did you hear me? So where I've got prompt, make this parseInt. Where I've got parseInt, make that prompt. And spell prompt correct. Now, let me run it again, double check and make sure it works now the way it should. See, please enter a number. See that? I'll just put in 55. Please enter another number, 45. All right, still doesn't like something. Nope, said that it was okay. I never told it to print this. See that? I took that alert out. So alert, str. All right. Now, trying to figure out why this didn't come up. So I'm gonna get rid of the double quotes. That really shouldn't matter one way or the other, but that should have given me a default value here. Ah, I know I didn't. All right. Comma, now put in 34. Like that. And now put in 56. Like that. All right. Let's double check and make sure that it works. And I'll put in something simple. 3 and 2. 3 plus 2, 3 minus 2, 3 times 2, 3 divided by 2, 3 modulo 2. So it works. My \ns may not be working the way they should, but that's okay. All right. In fact, I didn't put one here after product. That's why it looked a little funky. So let's look at this. parseInt, what it says is take whatever you put into here, and convert it into an integer. You may have tried this already, you may not have. Anybody want to guess if I leave it blank, what number it's going to put in there? If I don't put in anything. So I get rid of this 34 that pops up, so there's nothing in there. It gives me a special value that's called NaN, not a number. Just to show you, I'll do it the worst way I probably could. So I'm going to leave that blank, and I'm going to leave that blank. And notice how everything now is NaN. All right. I can even check, this is a little bit advanced, but I'm just telling you, I can even check to see if something that I put in is NaN, if I want to. I don't want to get into that right now because it's material that's in the next chapter. But I'm just telling you, we can check for that. All right. So again, looking at this, All right? It's expecting you to put in numbers. Does it make sense to you? It's expecting that what you put in will be whole numbers because it's parsing it into an int. So what if I don't want to do that? There's not only is there a parse int, there is a parse float. So if I wanted to change that, I could. All right, I'm going to come back and run this again. Now I'll put 12.8 and 2.345. Just making that up. You can see I get some god-awful looking numbers, but it works. All right. Now, what you may or may not have realized, again, you may have realized this, you may not have. I don't know. But I needed a \n before the modulus too. Whoops. Not there. There. All right. What happens if I come in here? I mean, does it make sense to you with a parse float? If I just put in 10 and 10, that's fine. But what happens if I go back to here and I make that an int again? And I save and I go run the program. And like we did before, I'll put in 12.8 and 2.6. And it all worked. What parse int does is it keeps looking until it doesn't find a number. In fact, this is one of the things that's different from JavaScript from most other languages. I can even put in this. This would be stupid. Don't ask me why I do this. The point is what I'm about to show you I could do. So in here, all right, I'm going to put in some goofy looking values on purpose just to see if the program will take them. So I'm going to come in here and I'm going to put in 34, but I'm going to hit the space bar and type in a bunch of letters and a bunch more numbers and some more spaces. And then I'm going to click OK. Then I'm going to do the same kind of thing here. 10, in fact, a 10, a bunch of minus signs, some letters, etc. And notice what it does. Still worked. As soon as it finds something that's non-numeric, it just disregards the rest. It truncates it or throws the rest of it away. All right. And then finally, as far as that goes, you may have already figured this out. You may not have. I don't know. But if I come in here and run it again, and I put in here ABC 1, 2, 3, and I put in here a space 4, 5, 6, and I hit enter, they're all NANs because it found a character that was non-numeric. As soon as it found that character that was non-numeric, it stopped. It just truncated the rest of it. So you can get some really kind of goofy looking things with this. All right, I actually went ahead because they just have the prompt, but I showed you the prompt with the parse int and the parse float, which are next. All right, the next one, this is one I almost never use. This is the document.write. So you can literally write something to your web page. All right, I'm going to grab everything that they have in here. You don't have to do this, but I'm going to grab all this. And I don't think it's going to let me, but I'm going to try it at least. No, it's not going to let me do that. So I'll do it like this. So I'm going to say script const today equals new date, which is going to give me today's date and time. All right. And then I'm going to just go right underneath it. In fact, let's put it over multiple lines because it'll look nicer. And I'll say document.write today.toDate string, I'm doing exactly what they have in the book here, script. So that's everything they had up here. All right, now I'm going to take my stuff that I put in here. It's all fine, but I'm just going to comment that alert statement out. So everything is still in there. All right. In fact, I'm just going to comment all of it out. I don't really need it for what I'm about to do. So I'll do a control / and I'm going to save that, and I'm going to come in here and try to run it. Didn't like something. Nope, it didn't mind it. Did I say I wanted to print it out, or didn't I? Where did I put that? Oh, I never copied it. So let me copy it over now. I'm just going to throw that into the body right here. So you see it. There it is. So you can use document write to write to a web page. There are other ways of doing it, and most of the other ways are considered better than this. This, again, is pretty much old school. It's not that it's wrong. It's just that since there are better ways of doing it, it's recommended that you use other ways. All right. What we'll get into later is talking about the DOM, the document object model, which is another way that you can write this stuff. It's much easier, to be honest with you. All right. So the chapter ends here, as it says, with these two illustrative applications. The first one's pretty simple. All right, it's a miles per gallon application. So when we look at this, it says the two prompts for the miles per gallon. All right, and then there's the result. Well, there's all the code. Now they put the code in line, so we could have pulled this out, but the point is, it might look a little funny because you might say, hey, wait a minute, they used const. You told us to use let. They use const and their variables aren't uppercase. You told us to use uppercase. All right? Believe it or not, even though it doesn't look like it, these are constant variables because once you set them, they're not changing in the program. So who cares? I mean, why would you use const as opposed to let? Const actually take up less memory and they're supposed to work faster. So you're supposed to use const whenever you can. There was, with the simple stuff that we're doing in here, it really doesn't matter too much one way or the other. All right? But you don't have to do this. But again, if you want to start learning how to do this, key in this program. All right, notice they used a document.write in here. They're actually writing out the HTML. You know what those tags are, etc. All right? And when you look in here, well, everything's in the body, but you could pull everything in between these two yellow tags out, put it into its own file, and then use a script tag to include that file. All right? But the point is, looking at this, is there anything that's in here that doesn't make sense? Now, did you have to do this? Parse float, miles divided by gallons? No. The reason they did the parse float, it's a really good, it's a good statement. What happens is, let's say again, I give a real simple example. So right here, how many miles did you drive? 17. How many gallons did you use? 3. I know that's a stupid thing, but you get the idea. The answer should be 5.6. If you divide an integer by an integer, it throws away any decimal part. So it's going to give you just the whole number portion. By saying parse float there, it's going to retain that. I wouldn't have done it this way. I would have made both of those parse floats. Just is easier to do it that way. Plus, with what they've done here, they didn't do it, but let's assume that we did it that way. So let's assume we make these changes. All right, so we come in here and we make that float with a big F. We make that float with a big F. We come in here and we don't need this anymore now. We just say, but I'm going to keep the miles in parentheses, because I'm going to say dot to fixed to 2 decimal places. Now I'm going to get 5.67. Does that make sense? All right. They've got a second application in here that's called test scores. Let me get rid of that. All right. It allows you to enter 3 test scores, and then it calculates the average. Pretty simple. One thing to realize, if you look at the example here, see this? You need to put that in parentheses, not there, but you're entering score 1, entering score 2, and entering score 3. You want to make sure it's possible that, well, in this case, it'll work just fine even without it, because you've got a total and you're dividing it by 3. Sometimes you'll have to put things in parentheses to get the right answer. You're going to see that in a later program. But if you look in here, what do we have? Total is going to be the total of the 3 test scores. All right, now, since we're not doing any validation in here, since we're not doing any validation in here at all, you can put 1,000, -56, and 1,000,000,000, and it'll work. All right, I think it's tomorrow we'll go into the if statement already. We'll put some validation in. I'll probably use this program or the miles per gallon and put some validation in. All right. So that's it. So let's take a couple minutes. I know I've been going a while here. Yep, just about 57 minutes, so I know I've been going a while. But before we just put it down for today, let's take a look at tons of stuff open here. So where do I have this? Where I put it? Let's see. Well, let's do this. I'm going to go out and just use one of you as a guinea pig for a second here. If we don't, yeah, we can do it that way. All right, and let's see. Nobody's going to see any of your stuff, but I'm going to go down to the JavaScript folder, and notice you've got all the apps in the book in there. So if you want to look at them, feel free. There are exercises that are in here, but I want to make sure I'm giving you the ones that they're assigning. So let's see. So here's labs. So let's look. So let's look for chapter 2 and see what this is. All right. You're supposed to be converting a temperature from Fahrenheit to centigrade. All right. There's a formula you can look up to do that. All right. I think what we'll do is tomorrow we'll do the first one of these together, just so you get an idea how to do it, what to do, etc. All right. So those are the labs. And for the homework, I think they ask you to come in and work with this scores one and make some changes to it. All right, I'm going to go back and look in it because I want to make sure, I'll do this tomorrow with you. We go through and you know exactly what you're supposed to be doing for homework. You know exactly what you're supposed to be doing for labs. All right, and then the last thing, where is it? I wrote this, it's nothing. Believe me, it's nothing. But let's see, first in-class example. I did this before class. I think this is the one I wanted to show you. Yeah. So I've got this. Run the program, and it says, please enter something here. So something. And it inputs it, and it shows you it, again, there and it shows, and it shows it to you in there. All right, both with template literals and non-template literals. All right, so I've got that. And I've got 2 or 3 examples. I'm going to go through this right now and grab a couple of these examples, and I'm going to copy them to a folder, and I'm going to send you the folder. So you've got some stuff if you want to start playing with this. Does that all make sense? All right. I did grade your tests. Unfortunately, I left them at home. All right. The Packers won last night, so I was a little bit excited to watch them win at the end. And to be honest with you, I left a bunch of stuff on the table because I woke my wife up too at the end of the game. But you'll have them tomorrow. If I think about it, I'll even put the grades in tonight when I get home. Otherwise, I'll do them tomorrow morning when I get it. But you'll have everything. All right. Questions on anything? So last thing, tomorrow then. As it says, the essential JavaScript statements. So we'll learn what I call structured programming. We'll learn if statements, we'll learn switch statements, and we'll learn 3 basic kinds of loops. JavaScript for the last 5 or 6 years now has closer to a dozen different kinds of loops. But we're going to talk mainly about the 3 that are used the most often, especially when you're first starting out. Those being the while loop, the for loop, and the do while loop. So that's what we're going to talk about tomorrow. The chapter is actually shorter than this chapter, but again, we're going to be working on an example as a class as we're going through this. All right? Unless you have any questions, that's all I've got then for today.